Okay, let's look at this concentration cell. So we have a voltaic cell is constructed with 2 hydrogen electrodes. So the way I drew the hydrogen electrodes are as follows. You have a beaker, and inside the beaker would be H plus ions and H2 gas. And the way you give the H2 gas is you pump the gas through this tube here, and the H2 gas will go inside the solution. Okay, same here. So we have the same thing. That's what a concentration cell is. You have the same exact substance on both electrodes. So then you need an electrode. So I'm going to draw an electrode. I'm going to draw a piece of metal here, just a small piece of metal, wire connecting the voltage here, and then another electrode here. So those are the electrodes. Okay, so you want the electrons to come from the left side. So you have hydrogen gas, H2. It will give away 2 electrons, and it will become the H plus here. So the electron will flow through this wire going to the right. So this must be your anode. And this is your cathode. The way I remember that as well is A, B, C, D. A goes before C in the alphabet, so electrons go from A to C. And also, anode is where this is H2 became H plus, so it got oxidized. It's where oxidation takes place. Okay, so the electrons here, which substance will take the electron? Will H2 take the electron, or will H plus take the electron? You're right, H plus will take the electron, 2 of them, and you will get hydrogen gas. All right, so it says a voltaic cell is constructed with 2 hydrogen electrodes. Here they are. Electrode 1 has a pressure of 1 atm. So this H2 that they're giving has a pressure of 1 atm and an unknown concentration of H plus. So this molarity here is a question mark. Okay, so this molarity is a question mark here. Electrode 2 is a standard hydrogen electrode as well. It is H plus is 1 molar, so this is 1 molar. And the H2 gas is also 1 atm. Temperature is 298. The measured voltage is 0.211. So there's a voltage here, and you're wondering, how can there be a voltage if they're both the same electrode, the same type of substance in each electrode? So that's because the concentration must be different on the first electrode here. It's not 1.00. If it were 1.00, it would be 0 voltage. And the electrical current is observed to flow from electrode 1 to the external circuit to electrode 2. So this is electrode number 1, they call it, and this is electrode number 2. Calculate the H plus for the solution at electrode 1. So they want this concentration here, and they also want you to get the pH. Okay, so let's go ahead and write an equation here. This is a non-standard cell, so you have E cell is equal to E naught cell, okay, which is going to be 0 because it's the same substance, minus 0.0592 volts over N log of Q. Okay, so let's plug in some numbers here. E cell is 2.11 is given here, 0.211, I'm sorry, 0.211 volts is equal to E naught cell is going to be 0 because it's the same substance, minus 0.0592 volts divided by 2 electrons are being transferred, log of Q. Q is going to be as follows. I'm going to put Q in another area so it's not so confusing. So we're going to do Q here is equal to. Okay, so Q is products over reactants. So we're going to go ahead and write the equations. This equation first, so H2. This is electrode number 1. We will call this the anode. I'll call that the anode. Arrow 2 electrons. No, it's electron. Erase that little thing. Plus H plus. This is the anode again. Oh, I forgot the 2 right there. There should be 2. Okay. Then I'm going to write this one. This is the cathode. I'm going to line up the arrows so it's not confusing. So 2H plus on this side. plus 2 electrons, arrow, and this is the anode, and this is the cathode. Plus 2 electrons makes 2H2, and this is the cathode. Okay, adding those together, I'm going to get, the electrons will cancel, H2 on the anode, right there, plus 2H plus on the cathode, arrow, 2H2 on the cathode, plus 2H plus on the anode. Okay. Then I'm going to write down the equilibrium expression. So it'll be H2. It'll be products. H2 of the cathode. That's molarity. Oh, that's the pressure actually. So I'm going to write big P, pressure of the H2 cathode, times molarity of the anode squared, because of the 2 right there. So that's that, divided by pressure of the H2, this is the anode, times H plus on the cathode squared. Okay, now plugging in the numbers, I think H2 on the anode, this is the anode, it is 1 ATM. Actually, all the hydrogens are 1 ATM. 1 ATM here, and this is also 1 ATM on this side, right? 1 ATM, 1 ATM. Okay, so I'm going to go equals. The pressure on the H2 cathode is 1 ATM. And the pressure on the anode is also 1 ATM. So that didn't really matter. Okay, so then the H plus on the anode. This one is the anode, right? It's a question mark. So this will be your X squared. And then the pressure here is, the molarity here is, did they give that to us? Oh, 1.00 molar right here. And that's a squared. Okay, ignoring all the units, you can combine the units again. You're going to get Q is equal to X squared. So plugging that over here, it'll be log of X squared. Okay, then you're going to solve for log of X squared. I multiplied by 2, divided by 0.0592. I got negative 7.13. Okay. Then I'm going to raise it to the power of 10 to get rid of the logarithm. This will cancel. 10 to the negative 7.13, I got 7.4 e to the negative 8. Okay, this is x squared. So x is equal to 3.57. Let me double check that. Okay, so that's x 2.7 e negative 4. And that is actually, what did I just find? X is right here, which is products. This is the H plus on the anode. This is the anode. This is the amount of H plus, which was the question mark. So it's the molarity of the H plus there. So this is the molarity of the H plus in the anode. Okay, and the question is saying, calculate the H plus for the solution at electrode 1, which is the anode. What is the pH? So I have to just log that number. 2.7 e negative 4. and I got 3.57 pH. Okay, so all they did is they put 3.57 pH here, or this much of H plus in one beaker, 1 molar in one beaker, pumped in some hydrogen gas, and got a voltage of 0.211 volts. Okay, that one is a little bit harder. I haven't really seen that one on the test, but I have seen something that looks like this, the practice exercise, which is a lot simpler. Pause the video and try this yourself. So I drew the cell, half cells. It says the concentration is made with 2 zinc solid and zinc plus 2 aqueous half cells. So here's the zinc electrode as a solid, here's the zinc plus 2, and there are 2 of the same substance. The first half cell has a concentration of zinc plus 2. This is 1.35 molar. And the second half cell is 3.75 E-4 molar. Which half cell is the anode? Okay, and what is the EMF or the voltage of the cell? So I have to consider which of these two will be giving away electrons. Okay, so let me think about this. So if it's going to the right, that means this zinc is going to give away 2 electrons to become Zn plus 2. Okay, so I can already tell that this would not be spontaneous because it's going to make this molarity of zinc as a product, as you can see here, it's a product. And since this molarity is high, it's not going to want to go to the right. So I think the electrons are going the opposite way. Okay, so let me tell you what I mean here. And let me show you why that makes sense. Okay, so what I'm going to do, just to make the electrons go to the right, I'm going to change these molarities. I'm going to put 1.35 molar over here of the zinc plus 2, and over here I'm going to have a small molarity, 3.75 E-4 molar. Okay, let's try that. So we have the electron is still going to the right. I tried to do that so it's easier for me. So I'm going to do zinc solid. There used to be a solid. It gives away 2 electrons to become zinc plus 2. And I know it's going to go to the right because, I'm sorry, it's going to go towards the products because this molarity is really small, 3.75 E-4. If it's really small, then this reaction would want to go forward instead of the other way. Okay, that's the molarity. Okay, let's try this half reaction. So I'm going to write, so this zinc plus 2, so this zinc plus 2 here takes in the electrons, right? And it becomes zinc solid. Okay, so the molarity here is 1.35 molar. And as you can see, there's a lot of these to go around. There's a lot of reactants to accept the electrons, so it's going to want to proceed to the right of this reaction. Therefore, I think I wrote this properly. Okay, so which means this is now the anode where oxidation takes place. And this is the cathode where it accepts the electron and reduction takes place. Okay? So now, which half cell is the anode? It's this one with a zinc plus 2 with this molarity, 3.75 E-4. So we answered that. What is the EMF of the cell? Now, to get the voltage. To get the voltage, you have a formula, right? So it is E of the cell is equal to E0 of the cell minus 0.0592 volts over 2 log of Q. Okay, so E0 of the cell is unknown. E cell is unknown. E0 is 0 because it's a concentration cell, minus 0.0592 volts over 2 log of, so now I have to solve for Q. Okay, solving for Q, I have two equations. This one, zinc solid becomes 2 electrons plus zinc plus 2. Okay, and the molarity here is 3.75 E negative 4. Okay, and then I'm writing this equation now, lining up my arrows. Zinc plus 2 electrons becomes zinc. Okay, and then this zinc plus 2 is 1.35 molar. Combining the two equations, I'm going to get zinc plus 2 with a high molarity of 1.35 molar, which is nice because that's a reactant, and the electrons will cancel. These zincs, they don't, they're solid, so you don't write them in the equation. So over here, it'll be to zinc plus 2, which is 3.75 E negative 4. So this is the 1.35 as the cathode, and the 3.75 E negative 4 is the anode. Okay, written this way, you can see that the number of molarity in the reactant is higher than the products, and that's what you want. Okay, so Q then would be equal to products over reactants, zinc plus 2 divided by zinc plus 2. Or this would be the cat, and this would be the anode. Okay, plugging in the numbers. Anode is 3.75 E negative 4 divided by cathode is 1.35. And you can see this is going to be a decimal number, which is what you want because it's going to be a log of a decimal is negative, and a negative makes positive, so you're going to have a positive voltage. Pause the video and try that, please. Okay, so I got 2.78 E negative 4. I plugged it into here, and then I did this math, and the total is 0.105 volts. Okay, so this electrochemical cell, even though they're the same substance, different concentrations cause a positive voltage because the molarity is going from a high molarity to a low molarity.